Good morning. So we're here to talk about the Sysinternals tools created by Mark Rusinovich and originally by Bryce Cogswell as well. Now, Mark always asks me, I just had an idea. So Mark always asks me, how many people came to your session? He never comes to my sessions. So I'm terrible at crowd estimation. So what I'd like you to do is count off, starting here. You say 1, 2, everybody, and okay. That's not going to work. Would you mind smiling for just a moment? We'll just take your picture and we'll do it that way. Everybody smile. I'm getting a lot of glare, so this isn't going to work at all. Okay. Sorry? Selfie. Terrible at this. Let's see. How do you do that? This way. Front camera. Everybody wave or something. There, this is the top of my head, and anyway, so the reason we're here is not to do that. It's to talk about the Sysinternals tools. How many of you have used the Sysinternals tools on a reasonably regular basis? Okay, good. So Process Monitor, Process Explorer, Auto Runs, ProcDump, Zoom It. How many of you guys present? I use Zoom It all the time just so I can see things on the screen better. So the Sysinternals tools, for those of you who know, those of you who don't know, are a set of very powerful, very valuable diagnostic and troubleshooting tools that originally came from a separate company created by Mark Rusinovich and Bryce Cogswell, acquired by Microsoft about 10 years ago. But the thing about the Sysinternals tools, above everything else, is that they are cool, right? Would you say they're cool? I mean, I can't imagine doing my job without them. But how cool are they exactly? Did you know, well here, just a point of reference. Did you know that 25 years ago this year, Visual Basic 1.0 was released? This is the 25th birthday of Visual Basic 1.0. Visual Basic is arguably one of the most important utilities critical to the success of the Windows platform over the last 25 years. But how many of you attended a birthday party for Visual Basic? Anybody? I see no hands. Did anybody even hear of a birthday party for Visual Basic? Did anybody sing happy birthday to Visual Basic? Let's just, happy 25th birthday, Visual Basic. Of course, you wouldn't go to a birthday party for Visual Basic, right? That'd be ridiculous. But to celebrate the 20th birthday of Sysinternals, Sami Laiho, who's presenting at this conference, held a full-day conference birthday party in Helsinki, Finland, celebrating the 20th birthday of Sysinternals. Why? Because Sysinternals is cool. And when I heard the idea, I thought, well, of course he would do that. Of course he would do that for Sysinternals. And so it was a full-day birthday party with a number of great speakers, many of whom are presenting here this week. And, of course, what do you need at a birthday party? Birthday cake. That's Mark Rusinovich. So yeah, this was, on the one hand, really cool, and on the other hand, kind of creepy. But it was a lot of fun. So what I'd like to do, I'm going to get into some technical stuff in a little bit that I think will be valuable for those of you who are new to the tools and lower technical, less technical, all the way up to the more technical. But first, I would like to spend just a little bit of time remarking on the 20th anniversary of the birth of Sysinternals, just go over a little bit of the notable points in its history. So this is what it looked like 20 years ago. It was called NT Internals. Mark Rusinovich and Bryce Cogswell formed this company, and they were based in Austin, Texas. And they called it NT Internals and released some free tools. This gave them a lot of visibility. They called it NT Internals until Microsoft's lawyers came after them and convinced them that the letters N and T put together formed a trademark that they could not violate. So they changed it to Sysinternals, which turned out to be a good thing when Microsoft abandoned the NT name, right? Do any of you even remember NTFS DOS? Okay, cool. This was something that allowed you to access NTFS drives from DOS, from Windows 95, et cetera. I use that a lot. Regmon and FileMon, anybody? Is anybody still using it? Ooh. Regmon and FileMon evolved into what? Procmon, process monitor. There is no reason to run Regmon or FileMon anymore. They're no longer supported. Anyway, this is what it looked like 20 years ago. Next, Mark built on that notoriety that he was getting for these really cool tools that reverse engineered Windows and managed to expose information that Microsoft's tools could not give you. He started reporting and showing up in the technical press, talking about things about Windows that Microsoft didn't like a whole lot. It was kind of embarrassing to them, the minor differences between NT Server and NT Workstation, and the absolute fragility of NT4 before Service Pack 4. It used to be that any application, any process running in user mode could send garbage data to APIs and crash Windows. It would blue screen because the bounds checking, the input validation in kernel mode didn't really exist. And so it was really easy to crash the entire system from any process. Now this was embarrassing to Microsoft, and of course it infuriated Novell, right? Anybody remember NetWare? I mean, they believed that they owned the market for super fragile operating systems that could be crashed with any single application, and now Windows NT was showing them up. Yeah, I do so miss NetWare. Mark eventually realized that by cooperating and collaborating more with Microsoft instead of publicly humiliating them would work out better. And one of the first ways he did that was to become the co-author with David Solomon of the Inside Windows NT series. He started co-authoring with David on the 3rd edition, at this point, Inside Windows 2000. This is now the Windows Internals series. The most recent one is Windows Internals 6th edition, parts 1 and 2, because it got so big they couldn't fit it into one binder. He started presenting Windows Internals seminars with David Solomon, like a 4-day seminar. These were really detailed and really excellent seminars, and also really highly priced. So they both did very well with that. Then, of course, he became a very renowned speaker at Microsoft and other conferences, including TechEd, and of course here at Ignite. His most popular session is called The Case of the Unexplained. This is where he shows real-world troubleshooting, taking real-world cases and showing how to troubleshoot and how to resolve them, primarily using the Sysinternals tools, but also using other debugging tools. He is presenting that here today at 4 o'clock. I advise getting there early if you want a seat, because it usually fills up. Mark gained a lot of notoriety in 2005 when he was working on a utility called Rootkit Revealer that showed stealth rootkit techniques in use on a system and could reveal the existence of a rootkit. Rootkits operate by stealth. They are not supposed to be detectable, and he came up with a tool to detect it. And while testing it, he discovered a rootkit on his own computer that had been installed by a music CD produced by the Sony Corporation. They were producing digital rights management software. They didn't want people copying their CDs, and they outsourced to some contractors to build digital rights management software and keep it from being defeated. And those people decided the way to do that was to use rootkit techniques. This cost Sony a lot, of course, and this took Mark from the realm of the technical press into the mainstream press. This got a lot of notice because this affected lots of people outside of the Windows world. Around the same time as this, Microsoft was talking with Mark and Mark with Microsoft about the possibility of coming to Microsoft and joining as a full-time employee. Here's a letter, an email from Bill Gates saying, we'd love to have you here. So that deal was concluded in 2006. Sysinternals and Mark and Bryce's company, Winternals, were acquired by Microsoft. Mark and Bryce became full-time employees of the Microsoft Corporation. The Sysinternals tools continued on. Mark and Bryce continued to work on them, and in a really cool way. They did not have to go through the standard program management, product management, marketing, et cetera, to get things out the door. They could work on a tool. For most Microsoft technologies at the time, a good idea could take months at least before it was actually in the hands of customers. In the case of Sysinternals, they could start with an idea, and within a week, you could have it in your hands because Mark and Bryce were allowed to continue publishing whenever they saw fit. There was another major change to the Sysinternals tools at this time, though. They were acquired by Microsoft, and I've already mentioned their lawyers, right? We employ a lot of lawyers. So every single Sysinternals tool, including the command line tools, gained an end-user license agreement, which is actually very, very important. This is an end-user license agreement that dictates the terms that you have to agree to before you can use a Sysinternals tool. And it seems like a pain, but you know what? This stops cybercrime because we know that criminals cannot use the Sysinternals tools because they would first have to agree to the end-user license agreement. And we know they can't do that, so that stops them from using the Sysinternals tools for nefarious purposes. It's really that easy. I mean, I don't know why we even have cybercrime. All we need are more lawyers and more end-user license agreements. Continuing on, they signed a deal in 2006 that was a contract for 4 years. I don't know the details of this at all, but there was a 4-year contract, after which I guess they got a big payout. So I think that the first thing Bryce did after joining Microsoft was to build an app that counted down the number of seconds remaining until the 4 years was up. And as soon as that was done, he's gone. He's retired. He's remained retired. Mark has moved on to the Windows Azure, the Microsoft Azure team, where he is now the Chief Technology Officer and driving the direction of our cloud computing platform. And he's doing talks here at Ignite about Azure. He was doing one yesterday with Jeffrey Snover. Did anybody go to that? A lot of people went to that. Anybody here go to that? Okay, there's a recording. 2011 saw the release of the Sysinternals Administrator's Reference, the comprehensive, detailed, accurate, and complete documentation of all the Sysinternals tools, as well as some background information about how to use call stacks and symbols and so forth, and some other background information about Windows internals that has not been well documented elsewhere. And this is where I come into the picture. I've been using the Sysinternals tools since the 1990s, but you can see here, actually, those of you in the back definitely can't see. My name is actually on the cover. Actually, those of you in the front might not be able to see it either. It's in 4-point font. Mark tells me that the reason for that is the font size has to reflect the relative height of the authors, and that's what he told me anyway. This also includes a case of the unexplained, and a number of cases of real-world troubleshooting cases showing step-by-step how the Sysinternals tools can be used to solve real-world cases. And so that's in there as well. So this came out in 2011. Everything in there is still accurate, but it's no longer complete. There are new tools that have come out. Many of the tools have gone through major revisions and have a lot of features that aren't documented in the book. So what to do about that? Second edition, troubleshooting with the Windows Sysinternals tools. How many of you have this book? Nobody. Well, you should all get it. I don't know why you don't have it. 40% bigger. ProcDump has gone through several major releases since the first book came out. It is now its own chapter. Sysmon and PSPing are now documented, new and updated features all covered. Deeper detail, for example, process monitor. In the first book, we described you can save a process monitor trace as XML. And that's all we said about it. This time, we document the schema so that you can use it. And there's two the unexplained cases that show the use of process monitor's XML output to manipulate the data in ways that are not really possible any other way. Case the Unexplained has been expanded. The first book had 17 cases. This one has 45. So where do you get this? Well, we just completed it. We gave the last bits we needed to give to the publisher last week. And they were not able to turn that into printed books or online books in time for Ignite, of course. So it will be available in late October or maybe early November, hopefully in October. We are taking pre-orders, or the bookstore here at the conference is taking pre-orders with a 25% discount. They've got coupons in the bookstore, which is in the Expo Hall, the Microsoft Conference store, I think in the far left as you walk in. We've got coupons up here that you can take. And Mark and I are doing a book signing. Now, how do you do a book signing when you don't have the book? Well, Mark has a number of other books that he'll be signing and selling, including Windows Internals and including his Cyber Thriller series. And for the new book, we're going to be signing labels. So you can pre-order your book, you can get a label, we'll sign that, and when the book arrives, you can stick the label in the book. That's what we got today at 2:30. Okay, enough of that. Let's start talking about some technical stuff. One thing I want to tell you about is Sysinternals for Nano Server. How many of you are familiar with Nano Server? Have seen any sessions about it? Okay, this is a new installation option with Server 2016. It is a minimal headless installation option. Okay, it has no GUI at all. How many of you have ever used Server Core? Server Core is morbidly obese compared to Nano Server. This has no GUI at all. It's intended for remote management only. It does not have a GPO engine. They just stripped out everything they didn't think they'd need for the scenarios in which Nano Server is targeted. It has no 32-bit support. And it requires only 640K of RAM because no one will ever need more than 640K of RAM. Okay, I am required to point out that this is actually technically an exaggeration. It requires a lot more than 640K. 256 meg of RAM is what Nano Server needs for a footprint. So how does this tie in with Sysinternals, and why is this an issue? Why do we need to do anything special for Nano Server? Because of the lack of 32-bit support. One of the features of the Sysinternals tools is that you just download one executable. There's no installation package or anything like that. You just download the executable and run it, and it works, whether you're running on 32-bit Windows or 64-bit Windows. Because Windows has always had 32-bit support, and it could run 32-bit processes on a 64-bit system. And in the cases where it needs an additional file, like it actually needs to run native 64-bit code, it could always, what it would do is the 32-bit executable would contain a 64-bit version of the program. It would extract that out into the user's temp directory and run it from there. Here, let me show you real quick on this machine. Process Explorer, let's bump that font up a bit. Actually, wait, I'll just zoom it. Well, here's an example. All right, there's Process Monitor, 32-bit. There's Procmon 64 running out of the temp directory. So what it'll do is Procmon needs to run native 64-bit code. And it extracts out into the temp directory, runs that, and then when it's done, the 32-bit program deletes the 64-bit program from the temp directory. So leaves no footprint behind. This is a problem in Nano's server. Back to the slide. Because the 32-bit program can't run. There's no way to run the 32-bit program to extract out the 64. So the answer to that is Sysinternals Suite for Nano Server. So you go to the Sysinternals site and you can download the full suite, or you can download the package of tools that run on Nano Server. You get the Sysinternals Suite-nano.zip, extract that out, and you see a lot of these, all the executables here end in 64.exe. These are all native 64-bit executables. These are all command line tools also, because there's no GUI. But all these now can run on Nano Server. And let me show you an example of that. I've got a session set up already. I can just log into it. Okay. And let's run, actually, let me, have you seen this feature? I love this feature in Windows 10. Alt-Enter on a console window. Anybody seen that before? I love this. I'm going to run ps-info. And what do you get? The end user license agreement in text form. Can't get rid of that. So you have to run with except EULA on the command line, and then you can get ps-info to run. And there's a new tool, or a new version of a tool, load order. Load order is an old program that was, it's a GUI program, runs on, I think it was last updated back in 2000 or so. What it does is it tries to enumerate the order in which drivers and services get started on a computer based on the various configuration settings, so you can see which ones will load first. There is now a console version of it, load-ord c64.exe. Again, we have to do except EULA. And this is on a Nano server running in the cloud. So now you can run your Sysinternals tools on Nano. Cool? A little cool. Exit PS session. By the way, because Nano uses PowerShell a whole lot, some other changes had to be made to the Sysinternals tools, and this applies to all of them. So it used to be that banner information, like the name of the program and the copyright and the link to the Sysinternals site, used to be piped to standard error, right? Console programs, command line programs, typically write out to standard output and standard error. You can redirect standard output with greater than. You can redirect standard error with 2 greater than. Everyone familiar with that mechanism? So it always used to be that the data that you'd want would go to standard output, and the banner information would go to standard error. So if you redirected standard output to a file, you'd only get the data. And then the standard error, the banner, would just show up on the console unless you redirected standard error as well. The problem with that is PowerShell thinks that if anything goes to standard error, then an error occurred. And that's not the case. And so there's this fight between Sysinternals and PowerShell. PowerShell wins. And so it now writes everything to standard output unless there actually is an error. So the way you get rid of this now is with a new no banner switch. This is for consistency across all the tools because -Q was used for other purposes in some apps, and so now no banner is the consistent switch you use whether you're on Nano or any other flavor of Windows, to not spit out the banner. So you need to do this, for example, with command lines like this, autorun C, du. It's really particularly useful when you're using -C or -CT for comma-separated values or tab-delimited values. So you don't want that banner in there. Okay with this? This is the last slide. So now what I want to get into is useful things that you can use. I'm going to focus primarily on process monitor and then proc dump and then how to combine the two. So hopefully there will be things here valuable for those of you who are advanced and those of you who are not so advanced. So first of all, let me find process monitor and start it up. And this is a program I wrote a long time ago when I was working on a tool called Lua Buglight to simulate different types of operations. So I'm going to create this file samplefile.txt in the root directory. I'm running as standard user, and that succeeded. And thank you. I wanted to linger on the slide a little bit longer. I love slides. I figured you did too. Sorry. Okay, I've started up process monitor, and I'm running this tool called, it's a demo tool. I've actually got it on my blog. I'm going to create, zoom in here a bit. I'm going to create this file, samplefile.txt, in the root directory of C as a standard user, and it's still succeeding on Windows 10. And I'll delete that file. Actually, I'll create it again. I may want to go back to that. Whoops. And let's create a registry key that we're not allowed to create. Sorry about this. Let's do software policies, some subkey, create key. Whoops. Local machine, create key, permission denied. Okay, I'm going to stop the trace here. Now, I've got the font size boosted up pretty high, which kind of messes things up a little bit, but I want to make sure you all can see it. So this is process monitor. Process monitor is tracing all file system and registry activity on the system. It traces network connections. It traces process activities such as processes starting and stopping, threads being started and exiting, images being mapped into the process address space, which is primarily DLLs. And it is the primary troubleshooting tool on the Windows platform for pretty much everything I've ever seen. So what you get here is for every single event, you get the time at which the event occurred. You have an icon which, when you're using the default font size, this actually looks a little better. This is the icon of the program, name of the program, process ID, an icon again showing is this a registry event or a file system event or some other event, the name of the operation, the path on which it operated, the result, whether it was successful or not, or what the type of failure was, and then additional operation-specific detail. Now, in the little bit of time that I was talking here, I captured almost 500,000 events, which is a lot. So one of the most important things you have to do with Process Monitor is filter stuff out. Filter out the stuff you don't want to see so you can get to the information that's relevant. So one way of doing that, you know what I'm going to do? I'm going to bring the font size back down and use Zoom it some more instead, because will I? Did that change anything? Huh, seem to have a bug here. So changing the font size. So up here on the toolbar, there's buttons for registry activity, file system activity, network activity, and process and thread activity. And you can toggle these and remove all the file system events and just show, for example, registry events, or just focus on process events and take everything else out. Okay, so here, load image. This is this process loading these DLLs and mapping them in. So that's one way to filter things out. Another way is with the process tree. You can use this to find all the processes that we're running in a tree view showing the parent-child relationship between them all. And you can find the process you're interested in looking at or the series of processes. So here, let's find a good tree of processes. Zoom it. Here's Zoom it and Zoom it 64. If I'm interested in both of those, I can select the one and say include subtree, and that will select only the processes or only the events associated with process ID 21036 or 25116. And just show the Zoom it events. Let's reset that filter. Control R resets the filter. One of the most powerful ones that I like to use all the time is when you have a process that has a window, some visible window, you click on the crosshairs icon and drag that across, and it identifies window objects underneath it. And then you release the mouse, it identifies the process that owns that window and sets a filter just on that process. And I did not anticipate that it would take this long. This is supposed to be a fast computer. Come on. It's like waiting for Uber. It tells you, 2 minutes, and it's really more like 7 or 30. So while we're looking at this, let's just give it another. Any questions while we're waiting for this? Audience requests. This is like waiting for Uber. Okay, so now we've got just events relating to this one process. Now we're down to 3,332 events. And what I typically do at this point is if I'm looking for problems, things that went wrong, I filter out the events that went right. So filter out success. So one way to, another way to filter out items is to right-click on a particular value. For example, here I can right-click on the operation column, and I have the option to include only events with that operation, or exclude operations with that value, or highlight them. I can also copy the name to the clipboard. What I typically do is I go to exclude success and remove all the success events. Reparse. What reparse means is an operation designated for one path is going to get redirected to another at a low level in the file system or the registry. So in this case, I typically exclude that. File locked with only readers is a low-level event that never matters. Name not found is pretty common. It looks for things all the time in various locations. I typically get rid of that. No more entries means that it was enumerating the values in a registry key and came to the end of the list. Buffer overflow, this happens a lot. It sounds really scary, but it's not the type of buffer overflow that involves I'm going to run arbitrary code on your machine. What this means is the program at a low level, the program had allocated a buffer this big, and the operating system said, yes, I have the data, but it's this big. And so it would overflow the buffer if it returned that. So typically what you'll see is after a buffer overflow result, the same operation performed, but this time the program passes in a larger buffer and gets the data it needs. So this is almost never an interesting event. So I exclude that. And here I'm getting down to that's never happened. Whose ringtone is that? Who's got their phone up that loud? Wow. So here we're down to access denied. Now you could just go in and set a filter for access denied, but you might miss other things like sharing violation, right? So I usually exclude events until I get down to the interesting things. And here, invalid device request, that might be an interesting event at some point. So let's see. I'm nervous about resetting the filter here. I'm going to go into the filter dialog and remove these. Okay, one other thing I want to show you is that I can save a filter. So here I've got it filtered on just this process. I can save that filter as all events for 23388. And then if I perform other operations like remove all the success events, I can go back in and load the filter that I had saved and get back to that state. So when you filter things out, you don't lose them forever. Another filter I apply a lot of the time what you want to find out is what changed on the system. What changed in the registry and in the file system? What wrote to the registry or the file system? So I'm going to go back to that filter dialog, and I should have pointed out a little bit more about what this dialog does. This gives you the most granular control over the filtering that you do. Okay, this lists, you have a bunch of different attributes. Every single attribute that Process Monitor tracks, you can set a filter on any of those attributes with various comparison operators, and then you put in the data you're interested in. So, for example, the one that I like to use a lot is category is right. And I include events where the category is a right operation. Add that in. Oh, and by the way, you see here that there's a whole lot of events, event types that are filtered out by default. So you can include or exclude events based on your criteria. And by default, Process Monitor filters out a lot of events that are normally not of interest to you. So normally, you're not interested in seeing what Process Monitor itself is doing. You're using Process Monitor. You don't need to see what it's doing. It also filters out auto runs and Process Explorer, and a lot of low-level file system events and NTFS management operations get excluded out, as well as, and this is an important one you need to pay attention to sometimes, process name is system. Anything happening in the system process in kernel mode or initiated from a kernel thread gets filtered out by default. So if you're looking at things that are happening in kernel mode, you need to specifically go in and remove this filter. But I'm going to go ahead and do category as right. Remove zoom it. And here are all the file system and the registry is not in here. Okay, so file system operations. So I tried to write to c:/samplefile.txt in the root directory. Standard user is not allowed to do that, but because of user account control, UAC's file and registry virtualization, it redirects to the user's virtual store. So you see this reparse operation, meaning it's getting redirected, and then a successful event writing to app data local virtual store. And here's another cool thing you can do with Process Monitor. Right-click on that, jump to And it opens up Windows Explorer, File Explorer, to that location, and there's the file that it wrote in that location. One other thing I want to point out here, there's a great option, I'm not going to demo it, called Enable Boot Logging. So as you've been seeing, Process Monitor is primarily a GUI application. You log on, you have an interactive session, you run it, you apply the filters, etc. But if you want to trace things that are happening before you have an interactive session, for example, early in the boot or during a user's logon, what you can do is enable boot logging. When you enable this, the next time you reboot, Process Monitor will have registered a kernel mode driver that loads very, very early in the process. And as you're running, it's tracing all that information and writing it to a log file. And it continues to do so until one of two things happens. One, the boot session is over, the machine shuts down, or you run Process Monitor interactively. It stops the trace at that point and gives you the option to save the data that it captured into a PML file, the native file format for Process Monitor. So one of the first things that the driver does when it loads is unregister itself. So subsequent boots, you will not be boot logging. One of the frequent requests for Process Monitor was to support some form of automation, because the only way that you could enable boot logging was to go in and enable it through this menu option. And the only way to save it as a PML file was to run Process Monitor interactively and go through the interactive prompts and say where to save it. So there was no real good way to automate that. Now there is. Command line options for Process Monitor now include enable boot logging and convert boot log. So now you can fully automate the entire sequence of capturing, starting boot logging. You enable it, you reboot, and then you have a scheduled task or a remote operation or something like that to convert to a boot log. And you no longer need to be interactive to do that. And you can do this with scripts for end users or whatever. So, good stuff? Okay, this thing keeps locking out. Okay, the next thing I'm going to show is proc dump. Close that. Proc dump, like I said, has gone through several major iterations. Now, what is proc dump? Proc dump is a tool that lets you capture a user mode process dump of any file. Now, what's a dump file? A dump file is basically a snapshot of the state of a process at a particular point in time. You can use proc dump to set criteria. When this target process here hits some criteria, exceeds CPU utilization, or exceeds memory utilization, I want to capture the state of the process so that I can analyze that and figure out what was going on. So let's do an example here. I've got a tool called virtmem-test64 that I wrote. This is available on my blog. This is a tool I wrote specifically, I did it while I was writing the book. I used it to test out various memory allocation and things like that and see what the different tools, how the different tools would handle it. So I'm going to start proc dump, and I'm going to say if the CPU utilization exceeds 70%, I'm going to write a dump file, virtmem-test. Okay, so if it exceeds 70% for 10 seconds or more, write a dump file. And use 7 threads, run CPU hog, and you can see that the CPU utilization is now way up there. And after 10 seconds, it'll write a dump file. What can you do with a dump file? There's several things you can do with a dump file. I do not have WinDebug in my path. This is a trick I like to do. Push D, because I don't want to have it in my path all the time. Program files, debugging tools. Whoops. Push D. You can set that into my path this way. The environment variable CD is the current directory, so I add it to my path. Up D, now I've got WinDebug. QZ dump file. So it captures the state of the process right at this time. Now, what can you do with a dump file? There's 3 things you can do with a dump file. You can open it in a debugger and run detailed analysis and figure out what are the busy threads and which threads are holding on to resources that these other threads are waiting on, and what is the state of virtual address space, and are things mapped correctly, and exactly how did the heap get corrupted. How many of you feel comfortable doing that? Me neither. I can't do that stuff. What you can do is run bang analyze -v, let it do a bunch of analysis and tell you what's wrong, and if that doesn't work, then you rely on the third option, which is hand off the dump file to somebody who knows how to do dump file analysis, and that's what I do. So the reason I'm showing you this is not because, this is true of both proc dump with dump files as well as process monitor. You don't have to be the expert in order to use the results of these tools. What both of them do, with process monitor you save as a PML, you hand that off to someone else and they can reconstitute, here's what was going on your machine. And the same with proc dump. You take that dump file, you can hand that off to someone else, and particularly with symbol files, they can figure out this is what was going on your machine. Or maybe you're doing IT support for a user, you can use proc dump and write a batch file that tracks here's what was going on with that process, because we can't replicate that on our own systems. So we're going to capture a process dump, hand that off to the developers or someone else, and figure out here's what was going wrong, here's where the bug is in the program. So the valuable thing to know in proc dump is how to specify the criteria to get the information you want to get. So I just showed you how to do with -C, you can specify if it reaches a certain CPU threshold. There's similar ones for memory utilization for arbitrary program count, what are those called? Those counters. It's in the documentation. It's in the book. You'll buy the book. So one thing I want to show here, though, is exceptions. Do I still have virtmem test running? I don't have it running anymore. Virtmem test 64. Okay. Let's talk about exceptions for a moment. I'm going to trace first chance exceptions. And so let's talk about what exceptions are. So exceptions is something goes wrong in the program, right? It tries to divide by 0, or there's a program-defined exception. There's an exception handling mechanism where one part of the code can throw an exception to be handled by some other part of the code that it doesn't know about. When an exception happens, it throws what's called a first chance exception. The exception gets thrown, and then some other part of the code can handle it. And if it handles it, you never know that the exception happened. Okay? If it doesn't handle it, then it becomes an unhandled exception or a second chance exception, and you see a crash. Let me show you a crash first. So before I start tracing it, here is virtmem test. I'm going to allocate and commit 100 meg of RAM, marked read-only, and then I'm going to try to write to it. And it crashes, right? This is an unhandled exception. Here's an exception that gets handled. I'm going to throw an exception and catch it, and you never see that the exception happens. A debugger attached to the program will see the exception. So if you're running a debugger, whether it's Visual Studio or WinDebug or ProcDump, you can actually see the first chance exceptions happening and decide whether to capture a dump file or just report it. Or do nothing. So I'm going to do ProcDump. E1 says capture first chance exceptions. Now if I throw this exception, and even though the program catches it, it captures a dump file. It captures information about the exception and then writes a dump file. Now the thing is, I may not be interested in every single first chance exception, so a really cool thing you can do is filter the exceptions by name, and if you set the filter to blank, it will never actually capture a dump. It'll just continue to monitor the exceptions and show information about them. Different types of exceptions. Okay, without actually stopping the program or capturing a dump. Now, what if you have a program that's crashing at random times, or different processes that crash at random times, and you want to capture a dump, but you cannot attach ProcDump to every single process that's running. You never know when the crash is going to occur. This is when you want to set up ProcDump as the just-in-time debugger, the AE debugger. And you need admin rights to do this. Show the command line syntax for it. To install it as the AE debugger. AE, the terminology, it's written to a registry key called AE debug. The initials AE are kind of lost to time. I believe it stands for auto execute. But anyway, you do -I and specify the dump folder. You can specify whether it should capture a full dump, a mini dump, or a mini plus dump. I'm just going to do the default here and do ProcDump I C:\demo. Yeah, just that. And so now it is registered in Windows NT current version AE debug with a command line. So now I'm not running ProcDump anywhere, and if this program crashes, I'll do an uncaught exception. Won't I? What happened? Let's do this again. There it goes. You see those console windows pop up? That was ProcDump. That was Windows launching ProcDump. Okay, on the fly. So I did not have ProcDump running ahead of time. A crash occurred, and it wrote that to, that would be this latest one right here. Or two of them, actually. Two dump files. Okay, that is particularly valuable. And if I go into my normal dumps directory, this is what collects on my system when I have ProcDump registered. So yeah, Microsoft Edge, quite a few times. No idea why. And some of the MSIT stuff, Microsoft Internal IT, their stuff crashes a lot. So let me now do a demo. How many of you recognize this device? It's a music player. It's actually a gramophone player that plays 78 RPM records. No, it's much newer than that. It's an 8-track player. No, it's a Zune. It's a Zune, 30 gig Zune. I love my Zune. And I was really disappointed when, after I upgraded from Windows 10 1511 to 1607, and when I'd plug it in, it crashed. Now, this is an interesting thing. This crashed. This is a legitimate process crash, but ProcDump didn't capture it. Why is that? The reason is because some programs and frameworks like the .NET framework put in their own exception handling mechanism. So the crash never reaches the operating system, it's handled by the .NET framework. And so procdump never actually sees it. So I want to see what's going on with that. So let me happen to know the thing it was running was program files zune, zune.exe. So what I'm going to do is launch this command line and see the first chance exceptions, launch the program and monitor it for first chance exceptions. So I see here file load exception, bad image format exception, but I don't know what files were running at the time, or what files it was operating on, what parts of the registry it was accessing. So what would be a great tool for identifying what was going on in the file system and the registry while that was happening? My mic might not be working. What tool would be ideal for monitoring what's going on in the file system and the registry while this is going on? Procmon, exactly. And I hope some of you have not seen this because this is a really cool feature. Reset everything here, start the trace, run this again. You see all this output that procdump is producing? There's a feature in Process Monitor that allows you to write debug output to its custom interface, and procdump does that. So let's go to the process tree and find procdump64 and zune.exe. And I'm going to include that subtree. I'm going to include events from procdump and events from zune.exe. Include subtree. And let's go to the first event in Zune. So I select the Zune process, do go to event, and it takes me to the first event when Zune starts. I'm going to filter out, exclude events before. So everything before that, I'm not interested in. I'm only interested in things after Zune started. So here's a bunch of procdump activity. Here's the Zune activity. What I want to see is where's that debug output? By default, that is under this category here called profiling events, which are hidden by default. So I have to enable profiling events. And I'm going to do Control F and search for debug. I think it's debug output. There it is. Debug output profiling. These are the events that procdump was sending to show up in the process monitor stream. And what I'm going to do is highlight that. I'm going to right-click on debug output profiling and select highlight debug output profiling. And now they're highlighted. All the debug output profiling events are now highlighted. And I can go from event to event, go to the next highlight with F4. F4 again. And here's the output here. So here's output exception 406D1388. Here is a file load exception event captured by procdump. Here's the file system events that were going on at the time. Program files Zune, Zune shell resources.dll. So now you can see you now have a merge. You have all the file system activity, registry activity, process activity, and exception events all in one stream, which adds tremendously to the value of Process Monitor. Is that cool? Okay. Any questions about any of that so far? Can you see where this, would this be useful for you guys? Are you going to use this? Are you going to tell other people about it? Okay. All right. I do have some extra time. I do have some other things I want to show you, but if there's any audience requests, tools you want to see, tools you were hoping to see, just go up to a microphone and say, hey, I'd really like it if you did this. Okay? So just go to a microphone if you want. One of my favorite features that I use regularly is tab delimited output, and I'll show you why. I'm going to go to the program files directory, the DU utility. This is based on the Unix DU utility. It shows you disk usage. So it enumerates through and it'll tell you, here's how much space is being used in this directory structure. So that could be kind of useful. Now this is better than looking in File Explorer because File Explorer does not take into account things like sparse files or symbolic links. If things are hard linked, File Explorer doesn't realize that and it will count the file twice. Okay? DU takes all that into account. But what I like to do is do tab delimited and take it down, say, 3 levels and pipe that out to a utility called clip.exe. Familiar with clip? Clip is a command line tool. It's one of the anomalies. It's a useful tool that wasn't from Sysinternals. It's built into Windows. The standard input that goes into clip.exe ends up on the clipboard. So I'm going to capture tab delimited output going down 3 levels and write it to the clipboard. And I forgot to do no banner. Write that to the clipboard. Open up Excel. Paste. Excel likes tab delimited. If you paste tab delimited text in, you don't need to go through all the dialogues and stuff. Just paste, and it puts them in columns correctly. And now you can do sorting and filtering based on, largest to smallest, for example, of actual size on disk or size. And you can do the same thing with auto runs. Autoruns C is a command line version of autoruns. Tell it I want everything, tab delimited, no banner. And there's a bunch of other options. You can get hashes, you can get digital signatures and validate digital signatures on the file. Autoruns is, let me tell you what autoruns is. Those of you who might not be familiar with it. Autoruns enumerates tons and tons of auto start extensibility points. Everything where something can be hooked into Windows to start automatically when you start the computer, when you log in, when you run Internet Explorer, when you run Office apps, things that are hooked in that might be running in the background that you don't know about. Autoruns enumerates all of them, and you can use this to find out. This is one of the most valuable tools I find for removing commodity malware. Because commodity malware tends to use standard auto start extensibility points, and it's pretty easy to take them out when you can find them. Now, they might hide in some unusual places. Autoruns lists lots of them, hundreds of them. And this is taking a long time. I didn't think it would. No requests. There's a request. Go ahead. Can we get that microphone turned on, please?
Hello?
Yeah.
Since Microsoft is going everything to PowerShell, is there any thought or... Can you hear me?
Okay. Now I can.
All right. Since Microsoft's going everything to PowerShell, is there any talk of putting a lot of the sysinternal tools in PowerShell? Or...
so turning them into commandlets?
Yes, yes.
I've not heard of that. I've not heard of that. That would be a really interesting idea.
I know a lot of them, you can chain them just like a lot of the PowerShell commands now. But
yeah.
I know Microsoft is always pushing towards the PowerShell.
Yeah, the closest right now really is output to tab delimited or comma separated and then parsing it, but it's all just text. There's no object types in there the way you would expect, like with PS commandlet, get process, where you can actually get attributes on it. That would be doable. That's a neat idea. I'm going to raise that with Mark. Okay, so this finally finished. Go to Excel. I have a little macro here that does the sorting and stuff like that. When I do this, the entry column, what I do is I take out the blanks from that because they're just headers. And then you can see different categories that auto-runs monitors, whether it's a profile-wide or user-specific auto-start extensibility point. So I can just see here, I can filter out and just show things that are hooked only into my account, but not necessarily other accounts on the system. The name, the description, where it's launched, what the command line is, et cetera. And a really valuable thing I normally do here, but I didn't want to because I thought it would add too much to the time, is look for digital signatures. Are they validly signed? So I do this on, for example, production servers and find out, is there anything here that claims to be from Microsoft that's not digitally signed, or from Hewlett-Packard that's not digitally signed. Now, there are legitimate programs sometimes that do that, but you want to look more closely when a digital signature check fails for something that is running on an important system. Any other requests? Next time I'm going to put it in the description, or in the subject. The title of the session will be Sysinternals Open Mic Night. That'd be cool. Assuming there are any questions. I mean, maybe everything's answered in the book. Hopefully it is. Question? Oh, can we turn on all the mics, please?
Hello. Quick question for you. So sometimes I'll use Task Manager to go see what's hanging on a process on the resource monitor side. I can analyze the weight chain analysis, get the thread ID, then open up Process Explorer and really investigate what functions are in that thread that are kind of hanging. But a lot of times I get stuck there. I see a lot of the functions within the DLLs, and I don't really know which particular function is causing the hang. Do you have any tips to kind of identify which function in that thread is the cause?
So this relates to symbols. So presumably you're looking at a call stack at that point for the thread, right?
Correct.
Okay, so you're looking at a call stack. And if you have symbols, then you can find out. A call stack shows where you are in a program, or where you left off in a program. And it consists of the name of the file, which is an exe or a DLL, the name of the entry point within it, and then an offset from that. And the thing that can be confusing is you need good symbols in order to determine what the actual entry point is, what the actual function name is. And for Windows files, we only ever publish public symbols, which are basically the entry points into the DLL and not the internal functions within it. So if you have your own program and you have symbols for your own programs, you can get private symbols which include every single function entry point, whether it's exposed in the DLL or not. So that's a valuable feature. One thing about the offset, so you'll have a name and then an offset. If the offset is really big, that typically means you're actually in a different function, and we don't. This is the nearest symbol that we could find, and a big offset means it's somewhere else in the file. Does that answer the question?
Thank you.
Sure. Okay.
Question?
Question. Yes.
There used to be a tool called AD Insights to track Active Directory traffic.
AD Insights, Sysinternals tool, yes.
that doesn't seem to work anymore. Is that a known issue?
Yeah, AD Insight. Before people who are leaving, make sure to pick up a coupon here or in the bookstore. I assume everyone here wants a copy of the book, and everyone wants to pre-order it here so you can get it as soon as possible with a 25% discount. AD Insight is a Sysinternals tool that looks at Active Directory operations, and yeah, it's been kind of problematic. There are known bugs. Some of them, I believe, will be fixed shortly if they're not already. It's kind of a tricky one to maintain because of the way it hooks in to Active Directory operations. Come to the book signing today at 2:30 or go to Mark's case, The Unexplained, at 4 o'clock and give him a hard time about it.
All right.
Because I have. I don't have any control over bugs getting fixed.
One more question.
One more question.
Is there any workaround to dump out a Kerberos token somehow?
I beg your pardon? I couldn't understand you.
Like troubleshooting any Kerberos issues? Like I needed to dump Kerberos tokens that are getting used to authenticate against Active Directory. Is there any other way to get at tokens?
Let's talk about that after the session.
All right.
Get more detail on that. Oh, good. We have a scrum here. You guys can fight harder for them, you know. Okay. I'd like to thank you all for coming. I hope you found the content valuable. Come up and ask me questions after. Look for me at the book signing, and enjoy the rest of Ignite.